3 prisoners were sentenced to death. One of them American, one of them German, one of them British. What is your last wish? They ask the American guy. He says, give me a Diet Coke. I'm on a diet. What is your last wish? They ask the German guy. He says, I want to give a speech. What is your last wish? They ask the British guy. He says, I want to get shot before the German starts his speech. Unfortunately for you guys, it is too late now. Because I'm already in the middle of my little speech about the grand theme of our age, about the rise of artificial intelligence, which is going to transform every aspect of our civilization. This is a robot that I drew more than a decade ago. This is the title of my little presentation. This I'm clicking is my name and how to pronounce my name. When I was a boy, I tried to figure out how can I have the biggest impact, and it became clear to me that I must build something that learns to become much smarter than myself, such that this smarter thing can solve all the problems that I cannot solve, and such that I can retire. And back then I said that, and I'm still saying the same thing, and the only difference is that more people are listening because on the way to that goal, and we are still on the way to that goal, we have developed a bunch of methods, deep learning as they are called, deep learning methods, which are now massively used by the most valuable public companies in the world. Here you see Apple and Google and Microsoft and Amazon. As of March 2017, these are the most valuable public companies in the world, and they're all using like crazy methods that we have developed in my little labs in Munich and in Switzerland since the early 90s. And especially one of these methods, which is called long short-term memory. Does anybody in this room know the long short-term memory? Okay, does anybody in this room not know the long short-term memory? I see we have a third group in this room who didn't understand the question. It's an artificial neural network which is inspired by the human brain. In your cortex, you have about 10 billion little neurons, and they are connected each to about 10,000 other neurons. And some of them are input neurons, where video is streaming in through the cameras, and audio is streaming in through the microphones. And then some hidden nodes are doing the thinking, and some of these nodes are output neurons, which control the muscles. And it's the same for our robots, where video and stuff is streaming in, and then in there some thinking takes place, and this network, the LSTM, long short-term memory network, is totally stupid in the beginning. It knows nothing because all these connection weights, these connection strengths are random. But then, over time, it can learn to do interesting things, such as driving a car or whatever, by changing these connection strengths in a smart way. And this is this is a basic LSTM cell, and names of a couple of guys who made it what it is today. And you may not know it, but all of you have it in your pockets as I'm speaking. Because on your smartphone, whenever you do speech recognition, whenever you say, okay, Google, show me the way to Geneva, what is happening? Well, you are waking up a long short-term memory, an LSTM network, which is listening to the signals that are coming in from the microphone. Every a few milliseconds, a new signal comes in, and then it has learned, by listening to lots of speakers, to translate from the waveforms coming in to text, and you can ask questions to a search engine and so on. This is now much better than it used to be. In 2015, Google replaced their old system by LSTM, and it suddenly was not only 5% better, which would have been good, or 10%, which would have been fantastic, but almost 50% better than what they had before. So this is now available to billions of users, and it's already all around us, LSTM and similar algorithms are permeating the modern world. So it's not that we are talking about the future, it's already happening. Google Translate also has at its core LSTM networks that have learned to translate from one language into another. And since November 2016, it's much better than it used to be. So some of you may have noticed that. Whenever you're talking to Amazon Echo, it talks back to you with a female voice. It's not a recorded voice. There's an LSTM network which has learned to sound like a woman, to speak like a woman. So although you may not know it, you're using it all the time. When we started this type of research in the 90s, computers were so slow. Very few people were interested in that. We could do only tiny toy experiments, but we have greatly profited from this trend, which has held at least since 1941, when the first program-controlled computer was built. Every 5 years, computers are getting 10 times faster. That connects to what Markus Schindler said before. Every 5 years, we are getting 10 times cheaper computers. Now we've got 75 years or more than that, which means we have gained a factor of 10 to the 15, 1 million billions within a human lifetime. And the trend doesn't seem to stop. And every 5 years, we are getting 10 times better neural networks, can train them with 10 times more data and make them 10 times smarter in a certain sense. By 2009, this was good enough to win all kinds of competitions. We can use that also for stock market prediction and all kinds of applications. The increase of computational power also helped us to train feed-forward networks, convolutional networks as they are called, to win all kinds of pattern recognition contests. In 2011, so 6 years ago, for the first time, Superhuman Performance in a computer vision contest. This was when computers were more than 10 times lower than today. So for today, we can do 10 times more for the same price. And it's going to continue like that because in the next 25 years, we are going to gain another factor of 100,000. We can use that for medical imaging, which is going to transform all of healthcare and already has started to do that. That is from 5 years ago, a competition that we won in medical imaging where the goal was to detect cancer. And the system was better than any traditional cancer detection mechanism, and it's going to be superhuman. Already is superhuman in several ways. Now today, lots of startups are focusing just on that because the field is so important, because 10% of the world GDP is healthcare, and lots of people are going to live longer and healthier through these methods. So AI for good is the theme of this conference. This is AI for good. All of healthcare is going to be transformed by that. And people mentioned the AlphaGo, which recently became the best Go player in the world, a feed-forward neural network, which is not quite as powerful as a recurrent network, but also very useful for board games, has learned by playing against itself to become the best Go player in the world. I'm happy about that result because the company DeepMind that achieved that was heavily influenced by my former students, including one of the co-founders, the first employee, and the first author of the recent Nature paper of DeepMind. However, in these board games, you still have a tiny little universe, you know, with Go, for example, 19 by 19 pixels, some of them black and white and so on, and that's all you need to know about the world, and that's why you can use a feed-forward network to map that to a good move, next move, and so on. But in the real world, it's really different because you get 100 million inputs every few milliseconds, and you still don't know what's behind your back. So that's the reason why you need more general purpose neural networks with feedback connections that can memorize past events and so on. And that's why this field is exploding now so much. You can then learn to drive cars and all kinds of things. You can even build systems that, and this is essential for the future of AI, that set themselves their own goals, that don't just slavishly do what people tell them to do or imitate people. No, they invent their own experiments and their own tasks to figure out how the world works, like our little tiny robot here, which learns like a baby to build a predictive model of the world, which always tries to better predict what's going to happen if I do these experiments. If I let apples fall down, how do they accelerate? And it can learn something about the laws of physics by doing these experiments. And it feels an internal reward for and a joy signal for figuring out stuff that it didn't know before. And this reward goes to the separate module, which is generating the action sequences and the experiments that lead to the data that is streaming in. So we can build an artificial physicist that is motivated all the time to expand its knowledge about the world and what you can do in it. We already have that. It's already running. It's not like this is science fiction. It's already working, and it's going to scale dramatically. So what is the near future? We will see systems that learn not only how to improve in a little domain here or a little domain there. No, they are going to learn how to improve the learning algorithm itself. Self-improve without any computational limits. My first paper on that was my first paper ever, my diploma thesis, 30 years ago. Since then, we have made great progress. I think in the near future, for the first time, we are going to have a little animal-like AI on the level of something like a little crow or a little monkey. And once we have that, the step to human-level intelligence is going to be rather short. Because look at evolution. It took about 3.5 billion years to evolve a little monkey, but just a few tens of millions of years on top of that to come up with human-level intelligence. And now remember, every 5 years we are getting a factor of 10. Every 30 years we are getting a factor of 1,000,000. Soon, for the first time, we are going to have little devices for a few euros, 1,000 euros or something, which can compute as much as a human brain. And the self-improving software is not lagging far behind. It's going to be used. This potential is going to be exploited. 50 years later, for the first time, if the trend doesn't break, we will have little devices for 1,000 euros which can compute as much as all 10 billion brains combined. Everything is going to change. Every single profession is totally going to be transformed. And what can we do to make sure that this is going to remain AI for good? We cannot prove that our kids would always behave reasonably, but we can educate them, and we can educate them to become valuable members of society. That's what we also do with our robots. We cannot prove that they will always be doing the right thing, but we punish them if they do wrong things, and we reward them for doing right things, and that's how they become valuable members of society. In the long run, however, it is clear that they are going to transcend us. I have no doubt in my mind that within the next few decades, nobody can say exactly when, for the first time we will have AI that is comparable to humans, and then very soon after that, superhuman in many, many ways. What is going to happen then? Of course, smart AIs are going to realize what we realized a long time ago, namely that most of the resources are not in our thin film of biosphere, but out there in space. Less than 1/100000th of the sunlight is hitting the Earth, and the rest is wasted at the moment. It's not going to stay like that. It's not going to stay like that. Of course, the AI civilization is going to set its own goals and expand in a way where humans cannot follow. We have a little company that is trying to contribute to make that a reality. NNAISENSE, which is about the birth of a neural network-based AI. So it's pronounced like nascence, birth, however, spelled in a different way in neural networks, artificial intelligence for AI. So our connection to Audi, Rupert Stadler just gave a talk. We had the first self-driving model car which learned without a teacher to park, without a teacher, no teacher showing it, like a little baby. What is going to happen when when AIs will be truly smarter than we are? And there's no doubt that this is going to happen unless we mess it up through a nuclear war or something. Well, they are going to expand, they are going to cover within a few 100,000s of years, and it's going to start in in this century, I'm sure. They are going to cover within a few 100,000 years the entire galaxy by senders and receivers, such that AIs can travel the way they are supposed to travel, namely by light speed, by radio, from senders to receivers. And that's something which is really disconnected from the old ideas of science fiction authors of the previous century, which also talked about colonization of the galaxy. However, they had to invent all kinds of silly things, such as warp drive, superluminal flight, and so on. Robots and AIs and self-replicating robot factories will be totally happy to stay within the limits of physics and do that expansion thing. We are not going to stay the crown of creation, that's clear. But we can still feel beauty in being part of this grander process. The universe wants to make its next step towards high complexity. This is much more than another industrial revolution. This is something that is comparable to the invention of life itself. 3.5 billion years ago, a new type of life is emerging from the biosphere, is going to emerge from the biosphere in a way where we won't be able to follow. And the universe wants to become intelligent. It's a privilege to live at a time where we can witness the beginnings of that and contribute something to that. Thank you for your attention.